Hi students, now we are going to derive an expression for the orbital speed of a satellite. First of all, what is a satellite? Satellite is any object which revolves around any planet in a circular orbit. So once again, let us take our Earth as the best example for the planet. The mass of the Earth is me and the radius of the Earth is RE. So above this, a satellite of mass ms is revolving in a circular path with an orbital velocity VO. So we want to derive an expression for the orbital velocity. So first of all, you must know that your rocket is used to carry the satellite. To launch the satellite, a rocket is required. So inside the payload of the rocket, satellite and fuel will be packed. So as the rocket flies off, at each and every stage the burnt fuel will be expelled out, and the final payload only is the satellite. So after reaching the desired height, say h above the surface of the earth, after reaching the desired height, the satellite will be projected horizontally or tangentially to the desired circular orbit at the desired height h. So this velocity is called injection velocity. The injection velocity, it is injected into the circular orbit from inside the rocket. Therefore the rocket is called satellite launch vehicle, SLV. Understand that? So the full form of SLV is what? Satellite launch vehicle. So the satellite is being launched or injected into the circular orbit tangentially or horizontally with a velocity called orbital velocity. With the same velocity only, the satellite will revolve around the planet. Okay, now you can see here, the radius of the earth is RE and the height above the surface of the earth is h. And the combined length RE plus h only is called as what? The radius of the orbit. This is a greater circle of radius R, where small r is equal to RE plus h. So that is called the radius of the circular orbit. So whenever a body is revolving in a uniform circular motion with a constant speed VO, it will be under the action of a centripetal force. Is it not? Who is the agent who supplies the necessary centripetal force to the satellite? There should be some source or origin for the centripetal force. That is nothing but the gravitational attraction exerted by the earth on the satellite. So in stable orbit, these two forces will balance each other and the satellite will be continuously revolving around the earth. So now, what is the centripetal force? Okay, so the centripetal force on the satellite, the centripetal force on the satellite is given by F centripetal is equal to, we have studied mv square by r, is it not? So mass of the satellite is ms and v square is nothing but v orbital square divided by small r, and that is equal to ms v square orbital divided by re plus h. So this is equation 1. Now the gravitational force acting on the satellite. So the gravitational force, which is also the source of this centripetal force, so that is F gravitational. So this is equal to, only its magnitude I am going to substitute. So this is g into mass of the satellite into mass of the earth divided by this distance square re plus h, okay, re plus h the whole square. So this is equation 2. If these two forces are equal in magnitude or they are balanced means, then the orbit of the satellite is said to be stable. It is in stable orbital motion. So for stability, okay, for stability, these two forces must be equated. So, F centripetal must be equal to F gravitation. So now I am going to substitute for centripetal force the equation 1. So this is M S B O square divided by Re plus H. On the right side I am going to substitute the gravitational force. So this is a capital G into mass of satellite into mass of earth divided by Re plus H the whole square. So this is Re plus H the whole square. Now which terms can be cancelled on both sides? You see, mass of the satellite can be cancelled. So this is MS. And can you see here Re plus H here totally cancels with the power. So that left hand side is what now? VO square is equal to GME by Re plus H, or V orbital is equal to square root of GME divided by Re plus H. So this is the equation required. That is, equation number 3 is the expression for the orbital speed or orbital velocity. Magnitude of the velocity is only called as speed. So my dear students, now you see inside the square root, mass of the earth and radius of the earth and the height only is there. Is there any term equal to the mass of the satellite here? No. What does it mean? A small satellite weighing 4 kg and a heavy satellite weighing 400 kg, both will have the same speed at the desired height. At the desired height h, satellite of any mass will have the same orbital speed. That you have to keep in mind. Okay? So this is the expression you have to remember for solving numerical problems in the NEET and JEE entrance exams and all. This expression will be helpful to you. Now I will recall. Escape speed also 4 terms are there inside the square root. Here also 4 terms are there. What are the 4 terms here? V orbital is what? GME by REH. G one term, ME is second term, RE is third term, H is the fourth term. Isn't that? Whereas in escape speed, 3 terms are the numerator itself. 2GM by R. Keep it in mind. Okay. So 3 terms were there in the numerator. Here only 2 terms. Okay. Now, suppose some satellites are launched for studying the weather conditions around the earth. Every day news they are saying the weather report, isn't it? Such satellites giving the report, sending the report about the rainfall, temperature, humidity and all, they are called as weather satellites, which are at very low altitude from 200 to 500 kilometers only. Okay. So, if H is very much less than the radius of the earth, then the same expression now, how we can write V orbital is also equal to what? Square root of G into ME divided by RE. Such satellites which are revolving in very close orbital height, they are called as earth satellites. So for them the H can be neglected. H is few hundred meters only, isn't that? A few hundred kilometers if you take also, comparing to 6,400 kilometers, the height can be neglected. Now, this GM by R, this also can be written as what is square root of G M into R divided by R square. I am adjusting the terms. I am multiplying and divide by RE. So that this GM by R square is nothing but small g. Is it not? So, V orbital is also equal to square root of what? G into RE. This is for the earth satellites, close orbits, just a few hundred kilometers above the surface of the earth. For them, what is the orbital speed? Now we are getting equation 4, that is what? V orbital is equal to what? Square root of G RE. But what is the expression we derived for the escape speed? For the escape speed, Square root of 2gr, is it not? So we can say that on the surface of the earth, the escape speed is equal to root 2 times the orbital speed, approximately. Understand? So this also may be asked as multiple choice in competitive exams. That is why I have written here. Now, my dear students, this is the expression for the orbital velocity. How do you define orbital velocity or orbital speed? It is the horizontal speed that has to be imparted to a body at a desired height so that it revolves around the planet, say Earth, with a constant speed. Okay? So that is orbital velocity. Now from this we can also extend this derivation for what the time period of a satellite. That is also very important. So now let us derive an expression for the time period of the satellite. So what do you mean by period of revolution? Time period T. It is the time taken by the satellite to revolve the earth or by any satellite around any planet once. To complete one circular path, how much time taken is called as the period of revolution. Very simple. Now the orbital speed also is equal to the distance travelled by the satellite in one circular path divided by the time. So how much distance it will travel is 2 pi into Re plus H divided by the period. Is it not? So we can get the expression for T, shift it to the left hand side and shift V0 to the right hand side. Okay? Or from this we can write T is equal to 2 pi into Re plus H divided by V orbital. For V orbital, equation 3 can be substituted, is it not? V orbital is in the denominator. So this also can be written as what? 2 pi into Re plus H into. Instead of dividing by V orbital, I can also multiply by the reciprocal of V orbital. Is it not? So that the square root of Re plus H will come to the numerator. So into square root of Re plus H divided by square root of GME. So square root of GME. Is it right, you see? Okay, children, now Re plus H whole power 1, is it not? When this term is pushed inside the square root, it will take a power 2. So T is now equal to 2 pi into square root of Re plus H whole square into Re plus H. Already it is inside the square root. So this is power 1 divided by GME is also already inside the square root. So that this can be written as what? 2 pi into square root of Re plus H, how much? Whole cube divided by GME. Understand? Once again, if you assume for Earth satellites which are revolving around the Earth at shorter heights, we can write H is very much less than Re. So for H very much less than Re, so Re plus H is nearly equal to Re itself. So I can write now T is equal to 2 pi into square root of Re cube divided by GME. Okay? So now I can write this also is equal to square root of Re into Re square divided by GME. This Re cube I split into Re square. Next what I will do, this Re square I can shift to the denominator of GME. Okay? Or T is now equal to 2 pi into square root of numerator. I will retain this Re. In the denominator I will write GME. So from here it is shifted down. So this is Re square. But already what is the relationship between small g and capital G? For substitution purpose only we have modified this denominator, is it not? So gm by r square. This is nothing but small g, is it not? So this is since this GME, okay, GME by RE square is equal to small g. Therefore, the period of revolution of the satellite is what? 2 pi into square root of RE by G. And this is equation number 5. So, for board examination, this together will be asked as a 5-mark question. It is very simple. Little bit steps are more, but very easy to derive. So, my dear students, how to define first orbital speed of a satellite? I told you it is the horizontal speed with which a body has to be projected at a desired height, so that it revolves around a planet in circular path with constant speed. Okay, how will you define time period? Time period of a satellite is defined as the time taken by the satellite to revolve around a planet once in a circular path. So the final equation for the orbital velocity, you have to remember this: V orbital is equal to square root of GME by RE plus H, and the time period of a satellite is T equal to 2 pi into square root of RE by G. I hope you must have understood them. Fine.